Hello everyone. Today we will be looking at composition of soil and soil bearing capacity. Soil bearing capacity is one of the most important elements in deciding type of foundation system for a particular building. So it's very important to understand composition of soil and how it affects soil bearing capacity. We will start this presentation by looking at very basic form of foundation where building is just resting on some stones arranged. This is a vernacular house form at village Chitkul, Himachal Pradesh. If you look at from little distance, you can understand their overall system. Now, if you look at this particular image, you can identify very advanced type of foundation with heavy reinforcement. There is a huge gap between these two types of foundation systems we saw, and there lies various types of foundations in between them. So question here is, what defines which type of foundation system to be used? So foundation selection criteria for building is defined by two parameters. One is load of structures and second is soil bearing capacity. Type of building defines the load of structure. Similar way, type of construction material and number of floor defines load on structure as well. Other parameter which define foundation system is soil bearing capacity. Now we will focus on term soil bearing capacity. What is soil bearing capacity? So it is the capacity of soil to support the load that are applied to the ground above. Now, at this stage, it is very important to understand soil, its composition, and its relationship with soil bearing capacity. Soil is composed of four different sizes of particles and organic materials. Clay is the smallest particle in soil, whereas gravel is the biggest particle in soil composition. In this image, you can compare the size of each element with each other. Based on the presence of these particles in more or less number, there are various types of soils. Broadly, they are classified as cohesionless soil and cohesive soil. In cohesionless soil, you can observe more presence of bigger particles like sand and gravels. In this type of soil, particles are bigger in size, there is friction between particles, surfaces are rough, and there are gaps between particles to percolate the water. Water holding capacity is less in this type. In cohesive soil, you can observe more presence of smaller particles like clay and silt. In this type of soil, particles are smaller in size. The surfaces of particles are smooth or greasy. There is no friction between particles and they are very close to each other. That means no gaps between particles, which leads to higher water holding capacity. In this particular slide, you will see different subtypes of cohesive and cohesionless soil and their soil bearing capacity. We will spend some time on this slide just to look at different types of soils and their soil bearing capacities. This particular slide shows how these two different types of soil behave under loading condition. When load comes on cohesionless soil, the smaller particles takes position in the gaps between bigger particles. In this type of buildings settles for some time and further there is no further settlement as there remains no gaps for movement. The cohesive soil has great capacity for water retention. This is why great expansion and shrinkage are expected in this type of soil. As a result, foundation structures can suffer from uneven settlement. So, in this particular video, we have seen different types of soil and its soil bearing capacity. In the next video, we will be looking at different types of foundation. Thank you very much.